Okay, this is number one. Okay, this is antiderivative. All right, very simple, right? Okay, antiderivative. Antiderivative, just follow the rule, okay?
Yeah.
Add 1 is x cubed and divided by same number. We already have 4 there and divided by 3 again, right?
Yeah.
This one is we use the rule, okay? So, and plus c. So, simplify x cubed over 12 is okay. 4 times 3 is 12. X cubed over 12 and plus c, that is the antiderivative, okay? Number 2, which of the following is an equation of the line tangent to the graph? Y equal cosine x at x equal pi over 2. The line tangent, when you have a line tangent, just find out the slope and a point. If you have a slope and point, you get the equation. Y minus y1, slope times x minus x1. That is a point slope form, right?
Yeah.
Point and slope form. After that, you can transform into slope intercept form. Okay. So, a little more thick. Now let's find a point first. Okay, we can find the first. This is the function f of x. So y prime or f of x. I'm going to y prime, okay, because they have used y there. Cosine x prime is negative sine x. That is derivative. So over here, y prime, when x equals pi over 2, we can find the slope, right? Minus sine pi over 2.
Yeah.
Minus sine pi over 2. Sine pi over 2 is 1. We still have negative sign there. Negative 1 is the slope. Now the next one is we need a point. X coordinate is given. We still need y coordinate.
Yeah.
Y coordinate from original equation, okay? You can put this number pi over 2 in the x. Cosine pi over 2. But cosine pi over 2 is 0. Okay, you need this one, okay? So the point is when x equals pi over 2, y equals 0. That's the point.
Yeah.
Now we got the slope and point. The equation is y minus y1 is 0. Slope is negative 1. X minus x1 is pi over 2. So y equals negative x. Negative 1 times another negative, that is a positive pi over 2.
Yeah.
This is the equation of tangent. Okay? So choice C is the answer. All right, number 3. That is derivative, always chain rule. Okay, chain rule, derivatives. That is the power over here. Take a derivative with respect to the whole thing about this one. So this already have 2 there, but 2 move down, right? 2 times 2 is 4. About this one. Sine square root x and 2 minus 1 is 1. That's fine. Now we're going, that's the second one. Second one is sine. What is the derivative of sine? Cosine. That's right. So inside we have multiplied by cosine square root x. After that, going into the x is what? Square root x. So we multiply its derivative of square root x.
Yeah.
Square root x is 1 over 2. That is square root x. Derivative is 1 over 2, move to the front, x 1 half minus 1 is 1 half, minus 1 is a negative 1 half. So this is 1 over 2, negative 1 half is 1 over x to the 1 half, that is square root x. So it's just simply 1 over 2 square root x. But instead of this one, we multiply 2, 1 over 2 square root x. Now simplify over here. 4 and 1 over 2x. Square root x is going to denominator. 2 over here, 2 is cancelled out. This is now 2 divided by 2. And numerator now what is that? 2, we have a sine square root x. Second one is cosine square root x.
Yeah.
That's it. Okay? So we have the choice D is the answer, right?
Yeah.
That is chain rule. There are 3 chains there. Okay? First one is this is power. Second one is sine. Last one is square root x. It's okay, right? There are 3 chains. That's why we multiply 3, 1, 2, 3 over here, okay? Now the next one, number 4, antiderivative again. This one definitely use substitution. When you take the denominator, x cubed plus 3x and minus 5. When you take a derivative, 3x squared and plus 3, right? You get this form, very similar. U equals x cubed plus 3x and minus 5. Take a derivative, du equals 3x squared and plus 3, and this is constant 0, but times dx.
Yeah.
Remember, we can say that x squared plus 1, 3 to move out, x squared plus 1, that is need a little scale, okay? dx. As you can see that there is x squared plus 1 and dx in there. Here, x squared plus 1 and dx. That's why this one definitely we can use substitution. This replaced with what? Divided by 3. 1 over 3 du, right? Now this one inside all u. Okay, now take a look. Its antiderivative now looks like this one. Not yet. Okay, this is u cubed replaced with u. X squared plus 31, that is 1 over 3. I'm going to take a 1 over 3 and du. It's okay? That's it. Now take a derivative. This is 1 over u cubed is a regular form. This one we set the irregular form. Irregular form. That's why we can't take an antiderivative directly. We can't. But when you choose this form using the after we use substitution, 1 over u cubed is what? Regular form, right? From you can find the antiderivative. I'm going to change the exponent. 1 over u cubed is what? U to the negative 3 du, right? Okay, use this one. This is exponent, okay? Now you can use the antiderivative. I'm sorry, that is not exponent, that's just the power, okay? Power. Power, the rule is, we still have 1/3 there. Plus 1 is u minus 2. You can divide by this number, minus 2, right? That's the power rule, isn't it? And the plus. So 1 over 3 times negative 2. 1 over negative 2 is negative 1 over 6. And the u cube is 1 over u square, right?
Yeah.
And the plus c. Now replace with the x squared plus 1 in the u. Negative 1 over 6. 1 over. You don't need to 2, 1 there. Just 1 is enough. Okay, another 1. And x cube, x squared, x cube, right? U is x cube plus 3x minus 5 n squared. N plus c. Okay? So we have choice D, right?
Yeah.
Minus negative 1 over 6 and down denominator x cubed plus 3x and minus 5 and squared and plus c, right? Choice C is the answer, okay? Choice D is the answer.
Yeah.
Okay, this one is right. Typical type of U substitution. Number 4 is okay, right? Okay. Now number 5. The function f is given by 4x cubed minus x to the fourth power. On what intervals is the graph of f concave up? Concave up by definition is second derivative is greater than 0, that is reset concave up. Original graph, okay? Two level up here. This is original. Second one here. Okay, two level up there. Okay, two level up. That is a concave up. Now let's find the second derivative. First derivative is this one. 3 move down. 4 times 3 is 12x n squared and minus 4 times x cubed. One more times. Second prime equals 12 times 2 is 24 and x and minus 12x squared. Now we're going to check out this one is positive. We have to solve inequality.
Yeah.
So better use right the formula graph over here, okay? This is actually what it is. Negative 12x squared, the graph is upside down, right? Okay. So we're going to find out 2x intercept over here. Highest degree, okay? This is actually negative 12x squared plus 24x, same thing. Okay? So highest degree negative is graph is upside down, okay? Open downward.
Yeah.
Now find out 2x intercept over here. You can find x intercept from here too, okay? What is common? Negative 12x is common, right? This is already a negative 12. Negative 12x is common inside it. Just the 1x second term will be 2. It's okay? So x equals 0 and x equals 2 over here. So x intercept there. This is the graph of what? Second prime.
Yeah.
So this is minus, plus, and minus. Second prime is positive. In this interval, the original graph f of x is concave down. That means f of x is concave up on this interval 0 and 2, right?
Yeah.
Or the other one is concave down. From negative infinity to 0 is minus is concave down.
Yeah.
And from to infinite, still concave down, okay? That's the number 5. number 6. X is 3 times y to the 1/3 equals to y, and dy dx at the point 2 and 8. We take right implicit differentiation, okay? Because we have 2y there. Actually, it's a little hard to express y in terms of x. That's why we take right implicit differentiation as it is. X derivative, this is implicit. Differentiation. Derivative of x is 1. Derivative of 3y 1/3. Y 1/3 is 1/3 move down. 3 times 1/3 is 1. So we don't need it. But we take up negative 1. We take up 1, right? 1/3 minus 1. Negative 2/3. But what is the function of x? So we take, right, multiply its derivative, dy dx. And the y, only one y there, okay? That is the dy dx. So you can combine this one, that is better. Dy dx. This one move the other side, minus y to the negative 2/3 and dy dx. So dy dx, we need to find this value, combine this one. I'm going to write this as a first. Dy dx is a common inside 1 minus y to the negative 2/3. That is equals to 1. Now we can express dy dx. Divide these terms, 1 minus y negative 2/3. That's it. Okay? Yeah, dy dx in terms of y, we need only the value of y. Okay, we don't need the y x. Okay? Depends on the value of y, okay?
Yeah.
Now y value of here 8. Dy dx. We need the y value is 8. Put this number y equivalent. 1 over 1 minus 8. Just a factor over here, okay? Always it's gonna work. Okay? Break this number, base number to 2 cube, isn't it?
Yeah.
And the minus 2/3. One over 2/3 times 1/3 is 3 is out. 2 to the negative 2, right? It's okay? 3 times negative 2/3, 3 is out. It's gonna be negative 2. 2 to the negative 2, I'm sorry. 2 to the negative 2 is 1 over 2 squared, which is gonna be 1/4. So finally simplify this. 1 over 1 minus 1/4. 1 over 1 minus 1/4 is what? 3/4. And take a reciprocal, okay? Flip the number 4 over 3, okay?
Yeah.
That is dy dx, okay? 4 over 3. Choice is this, okay? That derivative is always a slope of tangent at on the curve, right?
Yeah.
On the graph or on that graph at x value equals 2. Is okay?
Yeah.
That means what? When x is 2 over here, if a graph over here, when you make the tangent line slope, that is f prime 2, okay? Number 7. The first one is the power, second one is the exponent function. Okay, exponential function. Power function, the rule is x to the n derivative. N move to the front, take up 1 from n. Exponent functions, b to the x. That's the exponential function. Always b to the x, but we multiply it by ln b.
Yeah.
A special case. When you have e to the x derivative, e to the x, but we multiply ln e. Same thing. Base number e there. But ln e is 1. Okay, ln e is 1. That's why derivative e to the x always e to the x.
Yeah.
Okay. Antiderivative of e to the x still e to the x. Okay, so a very interesting number, right? E to the x.
Yeah.
Memorize this one, okay?
Okay.
So x to the 5 derivative. Power 5 x to the 4. Yeah, same thing, this one, power. Second one is the exponential function, minus 5 to the x. Same thing, 5 to the x. But we multiply the natural number ln 5, okay? So where are these numbers? Choice D, that's okay?
Gotcha.
Now x go to infinite. So we have a e to the x function, okay? E to the x is the exponential, but only one side asymptote there. The rule over here, the limit x go to infinite, e to the x. This is it, infinite. It's okay?
Yeah.
When x go to negative infinite, e to the x is what is that? E to the negative infinity. E to the negative infinity, 1 over e to the infinity. That's close to 0, right? So y equals 0 is asymptote. Only one side, the right hand side different, right? That is not the asymptote. Now put this number x and there. When you put this number x, but numerator is what? 10 is nothing, very small when x goes infinite. Negative 6 times infinite square still negative infinity, right? But bottom is what is that? 5 times 3 to the e to the x, positive infinity. What is this one? It's gonna be negative infinity, but still, how much big we don't know. That's right. This also we can apply L'Hopital's rule, okay?
Okay.
So that is the limit. X close approach to infinity. Take a derivative in numerator. 10 is 0. Negative 6x squared is negative 12x. Now down there, 5 is nothing 0. 3 to the x, what? Derivative is still 3e to the x. It doesn't change. Now put this number, infinite again, still negative infinity to positive infinity.
Okay.
Still we can apply one more time L'Hopital's rule, okay? Negative 12x, derivative is negative 12. 3 to the x doesn't change, 3 to the x. Now put this number one more times. But this is constant, but this is infinite. Constant over infinite is what? 0, right? That's the limit value, okay?
Okay.
This is number 9. Let R be the region bounded by the graphs of y equals to x and y equals 4x and minus x squared. What is the area of R? Just approximate which graph is the top, so the other one is which one is the bottom. We have to check it out first. This is quadratic. The graph is minus x squared. The graph it looks like this. We know that. The x-intercept, x is out. 4 minus x equals 0. You have two x-intercept. One is 0. The other is 4. So this is 0. This is 4 there. The graph looks like this way. There is what x sub symmetry. At x equal 2, there is x sub symmetry. Where is the highest point of view? Put this number 2 there. 4 times 2 minus 2 squared is 4. That is 8. 4, right? Yeah, 8 minus 4 is 4. This one is 4. That is the vertex. Is when x is 2, y is 4. Okay, the graph will pass through this vertex. Now the next one is y equal 2x graph. When x equals 0, y equals 0. When x equals 2, y is 4, it's going to pass this point. This is the graph.
Okay.
This is y equal to x. So anyway, on this interval, this is a closed interval, right?
Yeah.
So on this interval 0 and 2 anyway, this is the top. Top is what? 4x minus x squared is the top. Bottom, this one is y equal to x. The area is what? Top minus bottom, right?
Yeah.
Already interval is top function minus bottom. X derivative along the what? From x to 2, x-axis, 0 to 2. Top is 4x minus x squared.
Mm.
The bottom is 2x. Already simplify, we have two like terms there, okay? I'm going to write the negative x squared first. Negative x squared and the plus 2x and dx. So we need to take integral. Antiderivative of minus x squared plus 1 is x cubed, still we have minus x cubed over 3. Second one is x squared divided by 2 is what? X squared. 2 over 2 is what? 1, right? X squared. Take integral from 0 to 2. This number x is 2 in the x. Negative 2 cubed is 8 over 3. And plus 2 squared is 4. And minus, put this number 0 in the x. Both will be 0.
Yeah.
This is negative 8 over 3. And plus 4 is what? 12 over 3. Which is 4 over 3, okay? This area equals to 4 over 3. Choice B is the answer.
Okay.
All right, number 10. So this is the graph of f, not derivative, just the regular graph of f. This is a function of here, okay, with respect to x and f of x. They are related, okay? They are connected. So what is g prime 2? G prime 2 is what? We need to take a derivative, this one.
Yeah. Also take a derivative.
Yeah, so we have to use quotient rule. G prime x equals quotient rule is what? Fx prime, fx is what? Squared, okay?
Yeah.
Numerator is what? Derivative this one and times f of x. Derivative of x squared plus 1 is 2x times f of x. And minus, don't touch numerator, but we multiply the derivative f prime x. Numerator is x squared plus 1, I'm sorry. Numerator is x squared plus 1. From here, we multiply its derivative of denominator f prime x. That's it. That's the quotient rule.
Okay.
Now put this number x is 2 in there. Denominator f of 2 squared. Numerator 2 times 2 is 4. F of 2. 2 squared plus 1 is 5. F of prime 2. Now f over 2, we can find the value this on the graph over here. Where is f over 2? When f over 2, y is 3, right?
Yeah.
So f over 2 is 3. But we need f prime 2. Prime 2 is what? X equals slope of x equals. What is the slope of this one? You can use over here. You can use this one. Same slope, this one, okay?
Yeah.
1, 2, 3, 4, 1. 4 over 1 is 4, right?
Mm-hmm.
So using this one, substitute there. 4 times f over 2 is 3. 5 times f prime 2 is 4. Over f2 square, f2 is 3 and squared. Now numerator 4 times 3 is 12. 5 times 4 is 20. Over 3 squared is 9. That is equals to negative 8 over 9 is the answer, okay? Okay. All right, number 11. Another definite integral. This one you separate because they are all polynomial, okay?
Yeah.
X squared over x is x. X over x is 1. Just to simplify this way. Now let's find antiderivative. Antiderivative of x is x squared over 2.
Yeah.
You can divide by the same number.
Okay.
Negative 1 antiderivative is negative x. Take integral. Negative 1 and 1. Put this number 1 in there. 1 squared is 1, 1 over 2, and minus 1. That's the first. Second one is negative 1 there. Negative 1 squared positive 1, so it would still won't have. But negative 1 is that going to be positive 1. Okay, open the gate. 1 over 2 minus 1. Minus 1 over 2 and minus 1. This is plus minus cancelled out. Now we have still two numbers, -1, another -1, -2. The area is a negative number because the graph is what? Below the x-axis, okay?
Okay.
Because this is the graph looks like this way. X minus 1 graph is looks like this way. We take integral from -1 to 1 over here. Okay, they're both what? Below the what? X-axis, okay? Or you can find the way, if you can graph this way, you can find the answer from the graph too. This length is 2. This length, when x equals negative, that is -2, isn't it?
Yes.
Area how much? Base times height, 2 times 2, and divided by 2. The area of this one 2, but this is below the x-axis. That's why we put the y one more side, -2, right? Number 12 there. The table above gives selected values of differentiable function. It said differentiable. When they say differentiable, think about what mean value theorem. When they have given continuous, always what think about intermediate value theorem. Mean value theorem looks like this one. If f of x continues, differentiate this, we are doing mean value theorem. Differentiable
Yeah.
on some interval on a and b, then there exists some value of c such that there's a
The
slope between
interaction
these
of
2
the-
points.
Okay.
That is the slope of secant. There must be equal same slope between these two intervals. Slope is the same thing.
Yeah.
That is mean value theorem.
Okay.
If we have a and b there, we have 2 points over here. This is f of b. This is f of a. This is the value of y, okay? If we have a graph over here. There's just some differentiable means what? Smooth line, okay?
Yeah.
So f of b minus f of a over b minus a is what? Slope of this secant. That we said slope of secant called by average slope.
Yeah. Okay.
Same slope over here, right? Always.
Yeah.
That is just the same. That is the mean value theorem. By in which interval there must be a number of c's such that f is 2. You're gonna find the interval over there. But this interval equals 2, right? So which interval equals 2? We check it out. F prime c equal 2, okay?
Okay.
Okay, table, we need this one. 0 and 4. Between 0 and 4, these two intervals, these 2 points, they have the slope is 2. To use mean values, we check it out. 0 minus 8, first one is what? 0 minus 8 over x2 minus x1, 4 minus 0. That is -2. That is not 2. This is wrong. Now check out 4 and 8. This is y value, okay? y2 minus y1, 2 minus 0, over x2 minus x1, 8 minus 4. But slope of this 2 point is how much? 2 over 4 is 1 over 4, 1 over 2. That is not 2, right? So this is not correct.
Yeah.
Now 8 and 2. y2 minus y1, 10 minus 2. x2 minus x1, 12 minus 8. That is 8 over 4. This is 2. So we can apply mean value theorem on this interval only, okay? Because what? Slope of this 2 point, between 2 point already 2, right? So choice C is the answer, okay?
Okay.
Now finish the last one too. x2, y2 minus y1, that is 1 minus 10. 16 minus 12, that is equal to negative 9 over 4, that is not equals to. To use this mean value theorem must be C, okay?
Okay.
That is number 12. This is number 13. Limit with x equal to 0, sine x over e to the x minus 1. What is the limit value of this? Check it out already when you got this one, okay? Put this number 0 in there, okay? Is this a 0 over 0?
Yeah.
Or plus minus infinite over plus minus infinite? Use what L'Hopital's rule, okay? L rule. Put this number 0 there. Sine 0, numerator, that is 0. Denominator, e to the 0 minus 1. E to the 0 is 1 minus 1, that is 0. This is 0 over 0. Now we use LH rule, okay? L'Hopital's rule. Take a derivative. Same limit.
Okay.
Sin x derivative is cosine x. E to the x minus 1 derivative is still e to the x. Constant is 0.
Yeah.
I'll try one more. Put this number x is 0 in the x. E to the 0 is 1. Oh, not anymore 0. Okay? Not anymore 0. Just put this number there. That's it. This is our final. E to the 0 is 1 there. Not 0. Now cosine 0. Cosine 0 is, we know that has the value of 1, okay?
Yeah.
E to the 0 is 1 too. So 1 over 1 is again. That's the limit value, okay?
Yeah.
We use it just 1 times L'Hopital's rule, okay? This put. A particle moves along a straight line so that at time t is a greater rate equals to 0. Its acceleration is given 12t. At time t is 0, velocity of particle is 2. So that is the initial value of velocity. Velocity at time t equals 0, the velocity is 2. And also it gives us the initial value of position 2. Position according to x. X to the 0 still is 5. This is a position function.
Yeah.
So which of the following is an expression for positions function? Position is what? 2 times integral, right? You're gonna go up to level, okay? Up there.
Yeah.
Or you can use, okay, I'm going to give you, okay, usually we use this one. First one is that you're going to find the velocity function, okay? Velocity is what? AT
2.
integral, right?
Yeah.
So AT to 12t dt. What is the antiderivative of 12t? Plus 1, t to the 1 is 1 plus 1 is 2 divided by 2. So 12 divided by 2 is 6t squared
Yeah.
plus c.
Mm.
Now let's find the c there, okay? Initial value is 2 when t is equal to 0 from here. When t equals 0, initial is 2. So put this number t equals 0 there. 6 times 0 plus c, that's c. c equals 2, right? So from here we can decide velocity function is 6t squared and plus 2. And also you can apply fundamental theorem of calculus too. Vt equals what is that? V0 will be, right? V0 2 plus from 0 to t Vt 12t dt. It's same thing. You can use same t, doesn't matter, okay?
Yeah.
So Vt is what? 2, isn't it? V0 is 2. So this is a little different, right? This is a definite integration. This is what? Indefinite, okay? If you use, right, fundamental theorem of calculus.
Yeah.
So we start from 0. After 0 to t, take all sum of what? The rate will be Vt, right? But this is a variable t because we use a t there. You can change this one, okay? Other variable, it doesn't matter, okay? After that, you can put in the t into the t, it doesn't matter, okay? 2 plus anyway. 6t is what? 6t squared, isn't it? We're gonna take this one from 0 to t.
Yeah.
2 plus what is that? 6t squared, okay?
Mm.
Same thing. Now, acceleration, position function. I'm going to use my fundamental theorem this time. When t is 0, that is 5. So x0, that is 5. Take integral from 0 to t, velocity. 2 plus 6t squared, okay?
Okay.
x0 is 5. But this is better, actually, okay, if the initial value is given. So antiderivative of t plus 60 squared. 2t is antiderivative of 2. 60 squared antiderivative. Plus 1 is t cubed divided by 3 is 2. 2t cubed.
Yeah.
0 to t. So 5 plus. Put this number t there. 2t plus 2t cubed. This number 0, they are 0, out.
Mm.
You don't need it, okay? So the answer is what? I'm gonna standard, use the standard one. 2t cubed plus 2t and plus 5. That is xt, okay?
Okay.
So there are already two different ways, but you can use by anything. If you like this one, you can go this one, or you like a fundamental theorem of calculus, you can go this way, okay? Fundamental theorem is what? Always we have a f of b that is equals what? From f of a, we start f of a. But between f a and b, it's a derivative, okay? F of prime x dx. Is it okay?
Yeah.
If this is a function of t, you can use it. Instead of b, you use t, okay? As the f of a, kind of an initial value, plus a to what? T, okay? Instead of b, we use the t. F prime x dx, okay?
Okay.
Number 14 will be okay. All right. Move on number 15. We have piecewise defined function there. Less than or equals to 5, negative x squared plus 3, and x is positive, negative 10x plus 28. F defined already. Which of the following statement above f is true? What is this graph? Continuous?
Yeah.
Check it out. Continuous at x equals 5. It's going to be same height. Same height, continuous. Different height, discontinuous.
Yeah.
Okay? So where is it continuous? When x equals 5, actual value over here, okay? When x is 5, what is the actual value? F of 5 equals to how much? Negative 25 plus 3, negative 22. From left side, the approach is what? Negative 22 over there, right? Anyway, this is also a limit value, okay? Actual value and limit value to the left-hand side. One side, the limit value, okay? That means what? Limit x close to 5 from left-hand side, negative x squared plus 3, still negative 22, isn't it? And also actual values here, negative 22. Are you okay with this?
Yeah.
To be continuous, the condition of your to be continuous, f of x to be continuous,
Yes.
satisfied conditions. What is it? Limit value first. Limit x close to a, some number a continuous, okay? Continuous at x equal a, okay? Only this point continuous. Limit value, there must be just a limit value, but this limit value is just equals to what is the actual value, okay? Then f of x continues at x equal a.
Yeah.
And with this limit value from left hand side. Okay, now find out x close to 5 from right hand side, from here, this side. Close to 5, limit is the same numbers. Okay, there is a limit. Then we can compare. Okay, there is no limit, we cannot compare it. That's right.
Okay.
So negative 10x plus 28. Put this number 5 there. Negative 50 plus 28. Negative 22. Okay, from left, right, the same number, limit value. All together we can say limit x approaches to 5, f of x limit value equals negative 22. That's fine. But actual value, limit value is equal. Is it okay?
Yeah.
Actual value is negative 22, limit value also negative 22. So limit when x close to 5, f of x limit value is that equals to f of 5.
Yeah.
Then we can say f of x continues at x equals 5.
Okay.
On this value, they are continuous. You have f is continuous and differentiable x equals 5. This is, we just said what continuous, right? But
Yeah.
differentiable, we don't know. We have to check it out one more time. But not continuous. No, this is continuous. This is wrong. Neither. This continues anyway, okay? But take out differentiable. This is okay. Now f prime x. F prime x take derivative.
Yeah.
Left hand side, take derivative of negative 2x when x equals less than to 5. That is derivative. Second one is negative 10x, negative 10, derivative is negative 10, right? When x is 5. Now check it out when x is 5 from left hand side. Put this number 5 in there. From here we can say f prime 5 is how much? Negative 10, right?
Yeah.
From here, f prime 5 is how much? From right hand side, from left hand side. Still negative 10. Same derivative. Okay? Same derivative is what? The derivative exists. That is differentiable, right? We said, okay?
Yeah.
Smooth line. Derivative is only one number available, okay? Slope is only one. Okay? Yeah, so this function is differentiable at x equals 5 also, okay?
Okay.
That is number 15.
Okay. Yeah.
Number 16, dy dx is given by 2 minus y. If y is 1, x is 1. Okay? That's the point. When x is 1, y is 1. That's the point. But dy dx is given. That's the slope. Okay? But we're going to find the value of y there. Y value, function of y, which is what? Solution, right? Because this is a differential equation, isn't it?
Yeah.
To solve this one, separation, okay, always. All variable y to the left, all other variable x to the right. We have 2 minus y there. dy equals what? 2 minus y n times dx. It's okay. But the whole thing, right? We cannot separate this one. Whole thing move to the left. So you can divide by 1 over 2 minus y there, okay?
Yeah.
Now we got this one. 1 over 2 minus y is that equals to dx.
Yeah.
I forgot dy there. This is separation. This is called separations. And also this differential equation is separable, okay? This is, we said, separable differential equations.
Yeah.
Now take an antiderivative both sides. This is the log. It's okay. 1 over e minus y is what is that? Maybe you better switch right. It doesn't matter. If we have this one. 1 over y minus 2 antiderivative. What is that? ln y minus 2, right?
Yes.
It's okay? If we have 2 minus y over here. This is the minus ln y minus 2, okay? Or you can take my negative sign to the front. Out. That is a y minus 2 is now, isn't it?
Yeah.
It's okay? That's why, okay, from the beginning, when you have a 2 minus y there, this negative sign move on the other side, okay? Take this is the other side. okay?
Yeah.
So I'm going to take this one. Dx, I'm going to switch this one, okay? 1 over switch 2 minus y is y minus 2 dy minus dx. It's okay? The same thing.
Yeah.
That's the easier way, okay? So antiderivative of 1 over y minus 2 is ln y minus 2. The next one, negative x, okay? 1 is 1, negative x, isn't it? Derivative. And the plus c.
Yeah.
What is the inside y minus 2 absolute value is how much? Equals to what? That is the exponential form, okay? E to the what? Base number e to the minus x plus c, isn't it? Is it okay?
Yeah.
That is log expression, that is exponential expression, okay?
Yeah.
Now there is absolute value plus minus, okay? We can eliminate the absolute value. Now we got this one. X, y minus 2 is what? Plus minus e to the what? Negative x plus c.
Yeah.
So we're going to put this number c out, okay? E to the c times e to the negative x, isn't it?
Yeah.
But this one is also constant, right? This is also constant. So replace with the c again. Again, this is c1. After this one, put the c1, c1. There is now c, okay? You can let this is the c. So y minus 2 is equals to what? C e to the negative x. That's it. Let's simplify. Express y is over here. C to the e to the negative x plus 2 plus to both sides. Y equals c e to the negative x plus 2. We're going to decide the value of c, right?
Yeah.
From here. That is give some point over here. When x is 1, y is 1. When x is 1, y is 1. Put this number y is 1, when x is 1, plus 2.
Yes.
So put this number minus 1 there, okay? 1 minus 2 is 1, negative 1. C to the 1, e to the negative 1, okay? What is the c? Divided by e to the negative 1 there, okay?
Yeah.
What is e to the negative 1?
Mm,
Negative 1 over e to negative 1. 1 over e, isn't it?
yeah. Well,
That is exactly a negative e, right? Reciprocal,
yes.
okay? That is c. C equals 1, negative e, okay? Now, that's the solution over here. For this number, c equals negative e, okay? So that's the solution now, y equals what? C equals negative e times e to the what? Negative x and plus 2 is the answer. But this is the same base number. We're going to simplify again because we don't have this answer, right? So put this number by the what? Exponent operations, negative e to the what? That the multiplication exponent will be addition, okay? 1 plus minus x, 1 minus x, and plus 2. Okay, which one is the equivalent this one? Same as this one, okay?
Yeah.
2 minus e to the what? 1 minus x. This one takes a little time because this is a differential equations.
Okay.
Okay, we take a 5 minute break. Okay,
Okay, thank you.
take some water and take some fresh air. Okay,
I
I'm
will.
back here 9:18. Okay,
알겠습니다. Thank you,
five
doctor.
minute break on. Okay, all right. Okay, now let's continue the work.
Okay.
All right, number 17. G is the function g of x is given by the equation there. What is the x coordinate of point of inflection of a graph of g? Point of inflection, we have to check always what? G second prime.
Yeah. Okay.
Find point of inflection, we're gonna check this one first. And also before and after, they're gonna change concavity, right? Before and after, they're gonna change concavity, right? This is condition for inflection point. G prime x is first. dxd, that is G prime x is moved inside there. That is the fundamental theorem of second fundamental theorem, right?
Yeah.
This is function of x, but take a derivative with the same variable x. When you take a derivative again, so it's gonna be going into the t, right? So
Yeah.
g prime x is now equals to what is that? X going into the t, so x squared minus 5x and minus 14. That is g prime x.
Yeah.
This theorem is second FTC.
Okay.
Now we need second prime. One more. Take a prime over here. We already got first prime. No problem at all. Take a derivative of this one. 2x and minus 5. So 2 equals 0. At this value of x, they're going to have inflection point. 2x equals 5 and x equals 5 over 2. Before and after, they're going to change concavity, right? Definitely, okay? Because 2x minus 5 graph looks like this way. At this point, 2 over 5, they change. Negative 2, positive. Concave down to concave up.
Yeah.
Okay? Right. That's why at this point, 5 over 2, it is inflection point. Okay?
Yeah.
The next one, number 18.
Yeah.
Another chain rule there. Yeah, chain rule, but before that, we have to use product rule first, okay?
Mm-hmm.
This is my x cubed, that's the first one, prime, second functions.
Yeah.
This one don't touch, and we multiply second 2x prime. That's it, okay?
Yeah.
The first term derivative is 3x squared and times secant 2x there.
Okay.
Second term is x cubed, don't touch. Now this one is reset 2 times chain rule. There are the 2 chain there.
Yeah.
Secant 2x derivative is what is there? Secant 2x,
Yeah.
tangent 2x.
Yes.
But inside the 2x again, we take a derivative over 2x is 2, right?
Mm-hmm.
That's it. Now simplify here.
Okay.
3x squared secant 2x This is the move to the front, 2x cubed, and the secant 2x, and tangent 2x. Which will you keep on this form? 3x squared, secant 2x, after that 2x cubed, secant 2x, tangent 2x here, right?
Yeah.
Choice D is the answer, okay?
Okay.
All right, number 19. A particle moves along the y-axis so that at time t is positive or zero, its position given by here. That's the yt. That's positions. Vertical move, okay? Y-axis. By x-axis, y-axis, it doesn't matter, okay? So which of the following statement describes the motion the particle at time t equal 1? This vertical line. At time t equals 1, what happens? Going up, going down, or what about the velocity? Okay, they are talking about the velocity also.
Yeah.
The first one, position is moving up, moving down, and the velocity at this time, velocity is increasing or decreasing, speed up or speed down, something like that. Okay?
Yes.
They're asking you to this one. The rate of velocity. First one is what? Velocity is positive, that is moving up, right?
Yeah.
Moving right, moving up, same thing. Velocity is less than zero, moving down.
Yeah.
The next one is increasing means what? Velocity increases, V prime t, right? Acceleration, isn't it? I'm going to do velocity prime. This is acceleration anyway. If acceleration is positive, velocity is what? That means what? Velocity equals increasing, okay? Is it okay?
Yeah.
So, this derivative, that is acceleration, anyway, prime of velocity is less than zero, that means what? Vt is what? Decreasing. That's the meaning, okay?
Yeah.
Now check out velocity first. dy dt. Velocity equals to dy dt. Y prime t, okay? T cubed 3t squared. And the second term here is 2 times negative 4 is negative 8 n times t. And the voltage derivative is 4. Check it out this time. Velocity is positive or negative at time t equals 1. 3 minus 8 times t is 1 is negative 8 plus 4. Negative 1. Right? Less than 0 is the particle moving down. Now second is the velocity prime, which is actually right, the acceleration. Take a derivative one more time over here. 60 n minus 8. Put this number, time is 1. Time is 1 is what? 6 times 1 n minus 8 equals negative 2. This is less than 0. This is a less than 0 is what? This one. Less than 0 means what? Velocity is decreasing.
Yeah.
Which one is decreasing? Over here. choice A is this, okay? Are you okay with this?
Yeah.
This is number 20. Integral 1 to 4 f of x is 8. Another 1 to 4 same interval g of x is negative 2. Which of the following cannot be determined from the information given? The first one, g of x is definitely okay, right, from here. When you switch this one, upper bound is down over here 4, it's going to be negative, right, gx dx. But gx dx graph is already is negative 2. This one is negative 2. So negative 2 equals to 2. This is what 3 times 3 is out, 1 to 4 f of x dx. 1 to 4 f of dx is given already 8. So that is equals to 3 times 8 equals 24.
Yeah.
Now take a look, this is the first. This is 3 times 1 to 4 f of x. Constant already can move out. And the dx separate. 1 to 4 g of x dx. This is already given by the 8. Second one is minus 2. So 3 times 8 and minus 2 is what? 24 minus 2 is 22, right?
Yeah.
But what about the second one? 1 to 4 f of x times g of x. When you multiply these two, is this working? Product is not working every time. That's not the formula, right?
Yeah.
You know what I mean?
Mm-hmm. Yeah.
For examples, only area is given, okay? For example, f of x times this is a multiplication, okay? For example, f over 2 times f g over 2. Is this defined? Between 1 and 4, nothing. The only things they have only what? Area are given. 1 to 4, f of x area is what? This area is only 8. This is given. But we don't know what happens over here, the graph over here, okay?
Yeah.
Second one also what? 1 to 4 g of x, something like this one. Area is what? Negative 2. Okay? Area is negative 2 is what? Going down, right? The graph is maybe going down here. 1 and 4 going down there. This area is 4. Only area is why, but some of this area is why we know that. But when you take right some point of x, this is the f of 2, some value of f of x, another f of x. We don't know the value of this one, undefined. The height is undefined. We don't know from the given. It is okay?
Mm-hmm.
So f of x times g of x cannot be defined from the given. Are you okay with this?
Yeah.
Okay, so choice C is the answer, okay?
Mm-hmm.
The next one number, I think that is derivative functions. F of prime x, if you got the f of x there, if you got some f of x function.
Yeah.
F prime x limit used by h parameter. H close to 0. F of what? X plus h. and minus f of x. This is f prime x. That is definitions. Check it out. Is this the same form, right?
Yeah.
Or you can check it out. What is the f of x? F of x is the second one. This is what f of x. Okay. I'm going to write down this is f x plus h minus f of x over h, same form. But this time, what is the f of x? Sine 2x. Okay, put this number h, x plus h in the x of x. 2 times x plus h, that's sure. Is it okay?
Yes.
That is equals to f of prime x. If we write f of x sine 2x, this one is exactly what is there. Fx prime is sine 2x prime, isn't it?
Yeah.
What is the derivative of sine x? Cosine x. I'm sorry, sine 2x, right? Sine 2x, I forgot. Prime. Okay, this is exactly f of x prime. Fx prime is what? Sine 2x prime. Sine prime is derivative is cosine 2x, but we have to multiply chain rule, right? Times 2 there. Okay? So 2 cosine 2x is the answer, okay? This is a slope field. But check it out. When x equals 0, here all 0, right? Or y equals 0. When y equals 0, on this line, they are all what? Slope is 0, okay? All the group is 0. Okay? dy, dx, always 0. First, we should check out this one first.
Yeah.
Put this number y equals 0 there. 0. But it depends on the value. That is not 0, okay? Everything is okay? So that's not the solutions. Okay? That's not differential equation for this one, okay?
Yeah.
So y equals 0, that you know why. X can have any number, right? X can be 1, 2, 3, 4, right? So dy, dx, x, y equals 0, we don't know. It's okay?
Yeah.
Right. What if this y equals 0? Y equals 0. They are all 0, right? We still have two choices over here. Okay?
Yeah.
But there's no y there. No y means what is there? Always will borrow the x cube. But this is not x cube, right? The value over here, okay?
Yeah.
So we have two choices. C and D, only y equals 0, they're all 0. Now check out the next one. We're going to check over here some positive number. Choose this one. When x is 1, second one choose what? When x is 1, y is 1, right? When x is 1, y is 1. dy dx is a positive, isn't it? This slope is a positive slope. Yeah, both will be positive, it's okay. Now take out the next one over here. Another choice. Negative 1 and 1, it's okay.
Yeah.
Y is valuable. Take the other side, okay? We can take a negative number. Negative 1, negative 1, negative 1, okay? At this point.
Yeah.
X equals negative 1, y equals negative 1. Okay? At this time, slope is still positive. dy dx equals positive. Check it out. The y cube is only y, okay? We don't need the x. Y cube is what? Negative 1, right? Negative 1 is not positive. That's wrong.
Yeah.
Put this number negative 1 here. Negative 1 squared is how much? Positive, right? That is positive. That is true. So choice D is the answer, okay?
Yeah.
If you choose some point of it, this is not working, the other side, okay? Something like that. The base of solid region in first quadrant bounded y-axis and x-axis. The graph is y equal e to the x. E to the x is when x equals 0, y is 1. And the vertical line is 1 over here. This area, okay? Cross section perpendicular to the axis. So cross section is perpendicular to the axis this way. Cross section. It's a square, right? Looks like a square over here. We're gonna build a square. Okay? That is a solid. So we're gonna find the area of this square, okay? Yeah, this is length of base over here, okay? The square over here. We're gonna find this, the length of this one, the square over here. This is 2x minus y equals 0, okay? That is e to the x, isn't it?
Yeah.
The square is this side also e to the x, right? The area of this one, e to the 2x, is okay? E to the x times e to the x equals e to the 2x, x plus x 2x. That's the area of this square. We take area at this one from 0 to 1, right? Integral. 0 to 1, that's the volume, okay? Integral. E to the 2x and dx. Are you okay?
Yeah.
What is the antiderivative of e to the 2x? Still e to 2x but divided by 2. Because chain rule, we multiply by 2, but we go back divided by 2, okay? 0 and 1. Now put this number 1 in the x. E to the 1. 2 times 1 is 2. E minus e to the 0. That is 1 over 2.
Mm-hmm.
That is equal to 1 over 2 e to the square. And minus this is 1, right? 1 over 2.
Yeah.
Or is speech dance, okay?
Okay.
The number 24, the graph of piecewise linear function f is shown above. What is the value of 10 to 12 f prime x dx? But this one is what? F.
Yeah.
This is f prime dx. But it doesn't matter. We can use, right? This is the antiderivative of f prime x. F prime x, the antiderivative just f of x.
Okay.
Take integral from 0 to 12. It's okay?
Yeah.
That is equals what? F of 12 minus f of 0 from antiderivative. Where is f of 12? F of 12 antiderivative is negative 4 here.
Yeah.
Where is f of 0? F of 0 is 4. Negative 4 minus negative 4 is what? Negative 8 is this, okay? Number 25, the equation y equals e to the 6x minus 5 is particular solution to which of the following differential equations? I think, right, this is, we did it. That's the second order differential equation there. Okay, that's why we better use just checking the solution. Okay, y is given already. Y prime derivative. E to the 6 y prime is 6 move down 12. 2 times 6 is 12. E to the what? 6x. Y second prime is what? E to the 6x, but take derivative 6x, 6. Okay, times 6 again. 12 times 6 is what? 72. E to the 6x. That's all pass. Using this one, we can put this number into the A, B, C, D. Check it out. First one, A is what? Y prime 12 e to the 6x. 6 times y, times 6 of you. 6 times y is what? 2 e to the negative 6x minus 5 and minus 30. It is equal to 0, we check it out. 12 e to the 6x minus 12 e to the 6x. Negative 6 times negative 5 is a positive 30 and minus 30. That is what? All cancelled out. 0. That's the answer. Check right the third one only, okay? Y second prime is here. 72 e to the 6x. Minus 5 times y prime. I'm going to multiply by, okay, 12 e to negative 6x. And the 6 times y, it is equal to 0. Check it out. 72 e to the 6x. Minus 5 times 12 is 60 e to the 6x. 6 times 2 is what? Negative 12 e to the 6x. Negative 6 times negative 5 plus 30. It is equal to 0. Never be a 0, okay? But this is all 0. 72 altogether negative 72. We still have, right, cancelled out. 30 is not equal to 0, right?
Yes.
Only choice A is works, okay?
Okay.
Number 26. What is the value of x at which the minimum value of y, 3x to the 4th, third, and minus 2x on this interval? Zero and 1, okay? Minimum value is what? First of all, always, when you take right minimum or maximum, we always check right the derivative. First derivative test, okay? Because we need local maximum or local minimum, right? Y prime,
Yeah.
always. What is derivative of that first terms? 3 times 4 over 3 is what? 4 x to the what? Minus 1, 4 third minus 1 is what? 1 third.
Yeah.
And minus 2. Make it equal to 0. X 1 third equal to x to the 1 third equals 2 over divided by 4, right? Divided by 4. 2 over 4 is 1 over 2. What is the x cube, right? X cube is 1 over 8. Okay.
Yeah.
Okay, this is 1 over 8. Or you can sometimes you can use what's checking, okay? At this x equals 1 over 8, it has a relative maximum or minimum. We have to check it out. Put this number 1 there. At x equals 1, y prime equal how much? 4 times 1 third is still 1. 4 minus 2 is what? 2. That is a positive.
Yeah.
Well, then that's all you can use is x equals 0, 2, right? 0 is 0. Minus 2 is less than 0. That's positive. At this point, x equal, that is what? 1/8 is the minimum, right? The graph looks like this way. From all the way minimum, the next one is what? Increasing, right?
Yeah.
The graph this way. At x equals 1/8. So they're all, except this point, they're all higher than this one. So this point is what? Absolute minimum. It's okay. To the right, up. To the left, up. It's okay. Going down, going up, right? So this is my minimum point. That is absolute minimum, okay? So where? 1/8. Is it okay?
Mm-hmm.
Number 27. T0 storage tank is empty and begins filling with water. For T positive hours, the depth of water in tank is increasing. Okay? The depth of water is increasing at rate is what? WTP. This is already what? Rate. WT is the rate, okay?
Mm-hmm.
That's why unit is what? Feet per hour. Okay? So which of the following is the best interpretation from statement W prime 2 is greater than 3? It's a derivative over here, right? So W prime is a derivative of WT. If this is greater than 3 over here, it's okay?
Mm-hmm.
So prime again means what? It's a derivative of what is there? The rate of rate again, okay? Rate, another rate again. It's okay?
Mm-hmm.
That is why the unit will be feet, hour, another hour, okay?
Yeah.
All right. So 2 hours after tank begins filling the water, the depth of water is increasing at greater than 3 feet.
Yeah.
At the rate greater than 3 feet.
Mm-hmm.
So this is over here. But this is what W at time W prime T, right? Not WT.
Yes.
We are talking about the WT prime over here. This is already the rate, this is the rate of rate. It's different, okay?
Yeah.
Second one is over first 2 hours after tank begins filling the water, the depth of water is always what? Increasing at the rate of greater than, okay? Because this is positive. We just finished, okay? W2 equals 3 equals positive.
Okay.
It's okay?
Yeah.
3 is positive means what? The rate of water, filling water is increasing. It's okay?
Mm-hmm.
Right? Always what? Increasing at the rate is greater than 3 feet per hour? No. Just we know the increasing, but this one is a little different.
Yeah.
The unit should be feet per hour, another hour, okay?
Mm-hmm.
2 hours after tank begins filling the water, the rate of depth is what? Rising, increasing. That's okay, increasing. That is a positive increase, but the rate is what is there? 3 feet per hour, another power. That is the correct one. This is not, this is the unit is a different one, okay? Feet per hour is what this unit.
Yeah.
But we are talking about these numbers. Okay? From here, we can say that is positive, this is increasing. You know that WT is increasing, but the increasing rate is what is there? This one rate, but the unit should be this one. Feet per hour, another hour, okay?
Yeah.
But this is very similar, but this is the unit is wrong, okay? Wrong, they got the wrong unit.
Yeah.
It's okay?
Mm-hmm.
So we're gonna say this unit, right? Take a derivative again means what? Times t. Take a derivative time t again. dt d is what? We got one more time there. Are you okay with this?
Yeah.
Okay. So choice C is the answer, okay? What's the difference C and D? Over the first 2 hours after the tank begins, after 2 hours, okay? After 2 hours, not over two, okay? Entire hours, okay? The rate at which depth of water is rising. Rising, this is rising, that is increasing, okay? Rising and increasing. So choice C is the correct, okay?
Yeah.
The rising, this is the rate. That is increasing, it's okay? All right.
Yes.
Yeah, this is a little hard to understand, but I think they gives this type of questions every test anyway. But check it out, okay? This one is what? Check it out the unit over here, okay?
Mhm.
All right, number 28. A person stands 30 feet from P and watches a balloon of your 30 feet vertically from the point as shown in the figure above. The balloon is rising at a constant rate of 2 feet per second. That is rising up 2 feet per second is what? dHdt. That is what? 2 feet per second. What is the rate of change in radians per second of angle theta? We're gonna find this is what? When you're getting higher, angle increasing, right? Right? So
Yeah.
we're gonna find what? D set over dt, right? We're gonna find this one. Are you okay with this?
Mhm.
The balloon is increasing, the angle is increasing. So we're gonna find, okay, between theta and height, related rate. Okay. Now let's
Mhm.
find what is the relation between angle and height. Tangent theta, right?
Mhm.
Tangent theta is opposite over adjacent 30. So times 30, we're going to simplify. H equals what? 30 times tangent theta, okay? That's the equations. Now take a derivative of these two variables, h and theta. H and theta is both a function of time, dh
Yeah.
dt. Tangent derivative is what it is? Secant square over theta, it's okay?
Mhm.
But we take right d theta dt, okay? Inside the angle is a function of time, so we multiply the derivative d set and dt. It's okay?
Yeah.
Now dh dt is what given by number 2.
I got it.
Equals 30 and secant theta and d theta dt. But
Mhm.
at distance, we're gonna find what is the instant time over here. When the balloon is 40 feet above, at this situation, we're gonna find out. At situation,
Yeah.
h equal 40. This is 30. So at this times, what is the measure of this angle, right? It's okay? This is what the situations at this moment. I did 40, this is a fixed one. At this time, we have some fixed angles there. But we need to find secant theta, right? Secant theta equals how much? 1 over cosine theta, isn't it?
Yeah.
At this point, theta, this is 30, 40, this is 50, right? Hypotenuse is 50. Okay, using this length of side, we can find the cosine theta, okay? Cosine theta is what? At this moment, 30 over 50, okay? Let's break it, 30 over 50. 3 over 5. At this moment, the value of secant theta is 3 over 5. So this is 30 over 5 from here. 2 equals 30 times. Secant is 3 over 5 squared. And d theta dt. We're going to find the d theta dc over here. Now simplify. 30 times 3 over 5 squared is 9 over 25. D theta dt. So now let's find over here. D theta now, okay, now here. D theta dt equals what? 2 over 3 times 9 over 25, okay? This one, 9 over 25. 3 times, okay, quickly simplify. This is 5, this is 6. 2 over 6 times 9 is what? 54 over 5. So this equals how much? 2 divided by 54. 2 times 5 over 54, right? Multiply this one. 10 over 54. You can divide by 2 again. 5 over 27, okay? So the rate of angle, the rate of a change in angle theta equals 5 over 27 radian, okay?
Yeah.
This one is a little more work. Right, number 29, okay? After this, we'll finish today. How many vertical asymptotes does the graph over here? The origin factor, okay? X squared plus minus 4, x squared plus 4. Vertical asymptote is what denominator 0, okay? From that equation, we can find the vertical asymptote. But anyway, we have to eliminate the common factor over here, okay? X minus 2. This is x minus 2 times x plus 2. And the last one is the same as before. So, we have a common factor there. But this is not vertical asymptote anymore. At x equals 2, there is a POD, right? Instead of vertical asymptote, they create point of discontinuous, okay?
Yeah.
But this is no more cancelled out. So these two terms give us what vertical asymptote. First one, x plus 2 equals 0. So x equals negative 2. X equals negative 2, that is vertical asymptote. Second term is what? X equals plus 4 cannot be 0. Never be a 0, okay? Always positive. So there's no value of x. There's no vertical asymptote.
Yeah.
So x equals negative 2, only one vertical asymptote. It's okay?
Yeah.
Right. So I'm gonna post the video on YouTube and send out this to you. I'm gonna check, okay, the other video and the slope. I'm sorry, we didn't do that, the slope, okay? I'm gonna check it out, okay, your question, okay, after I send it out
Okay.
to link again, okay.
Okay, sounds good.